Last month I have visited Jimtov International Machine Tool Fair, and together with 125,000 people, I guess, we have been walking through this huge show, and it was like one of the biggest mold shops in the world, and it was amazing to see that most of the machines over there were actually 5-axis machines. It was amazing. And you could ask yourself, okay, is this the reality in my shop floor? Maybe not. But the innovation, and it was so attractive, it brings us to ask the question, how am I going to join this happiness? Is it good for me? How can I step up? So this is the actual webinar about. So we all agree that we want to improve our productivity, we want to shorten delivery time, and we want to improve surface quality. Each one of these is a challenge. Doing the three together, it's really a big challenge, and everybody would like to know, how can I improve in all those three parameters in order to become more profitable? So probably I would count 5 elements that we have to implement in order to step up. And that is, first of all, having a high-performance 5-axis CNC machine, have a good working holding device, have advanced tooling proper to my job, have in-process measurement, and the capable and probable 5-axis CAM software. Let us briefly go into those items. High-performance 5-axis machines. There are hundreds of types and many brands and many different machines. I would categorize them in 3 major categories. Table machines, as shown here, are mostly for small jobs where you can quickly rotate the part and the table, but the tool remains in the same direction. So those can be vertical machines or horizontal machines, but mostly for small jobs. Medium-sized jobs mainly will go on a combination of table head machines like those shown here. And the large jobs like the bumper molds and very large parts will go on a head machine, because you don't want to rotate a 3 or 5 ton part very quickly. Probably it will not be so efficient. So choosing the correct 5-axis machine by itself is very crucial, but you have to understand just the beginning that we have those 3 categories to work with. Work holding devices. If we want to minimize the machine downtime, we want to utilize very effectively the mounting of the job on the table. So we have those systems like System 3R, Aerova, or custom-made devices where you can mount your piece, your workpiece, on some plate, and you have a device connected to the table of the machine, and those two together are connected very quickly with item number 3, very quickly and very accurately and with high repeatability. So that will give us a minimal downtime, very accurate clamping, and in this way you eliminate errors and you are efficient. Tooling. Today there are many new kinds of tools like chatter-free inserts for long tool life. There are the high feed tools for large sidestep which will give you high material removal rate. And there are the solid carbide tools, which are rather expensive, but with very large downstep can give you a very high material removal rate in roughing, which is very interesting. You have different kinds of holders for different jobs. Let me emphasize here just the shrink fit, which is very accurate, or the power chuck, which will give very strong forces to drive the tool, yet not to pull it out and be accurate. In process measurement, today, when we want to utilize the machine to its best, we can implement measurements before starting the machining, like measuring the block and setting the correct home setup, or laser check the tool length and the tool diameter and then update those parameters into the machine. During the machining, there is the sister tool support that in a command from the post-processor you can call a sister tool in order not to stop the machining and again minimize machining downtime and control the machining. And at the end of the machining, you can measure a few dimensions, update the home, update the tool diameters, tool lengths, or if a breakage occurs or the tool is worn, you can terminate the job. So all that can be controlled through the in-process measurement during your work. So, and the capable 5-axis CAD/CAM software will elaborate on that later. So you need probably to look at those 5 elements when you want to implement high productivity in your shop floor. What does the 5-axis CNC machine will allow us? Basically 2 things: efficient setups and shorter tools. It goes all down to those 2 components. And together with efficient setup and shorter tools, you can achieve improvement in productivity and improvement in profitability. What does it mean, efficient setups? On the left side, we see a major operation in the front of this cavity mold. But on the right side, we see that we can, on the same setup, if we rotate the table, we can operate some additional operations. This means I can use one setup for several operations. This is effective. What are the advantages and benefits of efficient setup? First of all, improve material handling at the shop floor. Less machine downtime. Machine is the most expensive parameter on your shop floor. Whenever the machine is not operating, you are losing money. So if you can minimize the machine downtime, you are now becoming more efficient. And this means improved productivity. Overmore, you can be more flexible at your shop floor because there is less constraints of moving the job from one machine to another. So again, you have more flexibility. You can respond to shorter series of parts or to any changes happen on your shop floor. And you will get better blending, improved quality, because each setup reduces the quality or requires more time to get to quality. And also you can eliminate human mistakes because of manual input and because of extra setup job. So efficient setups is a very important target at the shop floor. Shorter tools. On the left side we see a radius at the bottom of this mold component that has to be milled with a small diameter and a long tool. On the right side, same tool diameter but much shorter. Because the head is tilted or the tool is tilted, you can get closer to the job with the holder and the tool, everybody can feel that immediately, is more robust and therefore will cut better. What are the benefits of shorter tools? First of all, less vibrations. Less vibrations means the tool is in its comfort zone. It can be, it dramatically improved surface quality and increased tool life. Even though the tool is not our target, okay, machining effectivity is our target, but on the side we can also increase tool life. Cut effectively, this is dramatically, with bigger downsteps and with faster feeds. And later on I will show you a real example how dramatically that can be. And if you cut machining times, you are effective, you are productive. And last, utilize smaller diameter tools. This is very important. In Japan, they initiated maybe in the 90s what they called the direct milling, which means take a rather small diameter and go down to the very bottom of the corners and the ribs and use less EDM. EDM is a very expensive process. It's time-consuming. It needs a lot of setup. It needs a lot of handling. And if you can eliminate the EDM, you are ahead. But what happens if the needed tool is too long? Then the direct milling is not efficient. But with tilting the tool and smaller lengths of diameter, when it's hanging out less, then direct milling becomes very, very attractive, and this is very good. Here we see a few examples of part production with 5-axis, and those are actually the aerospace, let's say, and the defense are the most traditional requirements for 5-axis, and those really started in the 80s and the 90s, like aerospace beams and impellers and blisks and blades and so forth. Those parts actually you can't cut unless you have a 5X technology. Later on, many other industries came in, like consumers, energy, and recently the medical. And with the medical, it's, you know, the human implants and so forth. Those parts are very difficult to machine. Actually, they don't have even one plane which is straight, and the handling of such a job is really a challenge, and 5-axis is a very big advantage over here. More interesting is with mold making with 5-axis. This is not trivial, because actually a mold is a component which don't need in its basic machining 5-axis. It can be cut in 3-axis. If we look, for example, we have here the standing core, or the opposite, we have the deep cavity and the large cavity. Those parts don't require 5-axis. But if I utilize the 5-axis on those even not required, I can leverage the productivity to higher levels. Rubber mold is a different example, because over there we have undercuts and the 5-axis is really required. Narrow ribs and small radius are again the same problem from different perspective, where we want to utilize the small diameter tools but with a shorter hangout. Let us see some applications that go with 5-axis. So people may say 5-axis, okay, everything has to run continuously, and all the axes X, Y, Z, B, C have to go simultaneously. No. As you can utilize the machine with less moving axis, your machining is more rigid, more robust, and the result is better. So 3+2 axis positioning is a very important niche, or actually the opposite, very important application for 5 axis. So mainly, let us start with roughing and finishing. Here again we see this standing core. In 3 axis we will need this extra long tool, which is available and people cut like that, no problem. But imagine you could cut this job from several orientations from the side. Immediately you can sense that the result will be easier to machine. This is the stock as it looks like after first operation, and here after second and after third. We can color the stock per orientation, so it's easier for the programmer to understand the process. And if we have a very large cavity, like bumper cavity, this mold can be like 2-3 meters in size. The whole head of the machine is sunk into the cavity. So here, it's better to find the orientation which would be the best and the optimal, and I would like to find this orientation before I go to calculate a tool pass for finishing, for example, that could run 30 minutes or 1 hour. So we see here that the application will give us the ability to look and find for the best orientation before the procedure was calculated. So we see now, we go into the procedure, click on the axis, the machine is loaded with its structure and with its post-processor commands. You can manually play with the axis. Whenever it's red, this means there is a collision. So you can find your space of orientation, rotate the head and tilt it to the proper position, stick the tool to the area that you want to machine, like this green area, and when you zoom in now, you have the safety even to change the tool to a shorter tool. And immediately, when you are using a shorter tool, you're utilizing the machine more effectively. More effectively means productivity. So once you have found the correct position, now you go, execute, calculate the procedure, and you're safe because you have already checked the position before calculating the tool pass. So also for the programmer, we find efficient solutions to be optimal. Next, swarfing. Swarfing is a very simple operation. It's a 2.5 axis operation. But the difference is that I will use this operation in a certain point where I want to utilize the tool to its maximal machining on a 3-axis job. If we look at this part, for example, and I want to swarf over here, if I had cut in 3 axis, it's kind of sculpturing and it would be not so efficient. But if I could machine this from the side, then I utilize the whole flute length of the tool, and in one profile operation I remove a lot of material in a very good surface quality and very controlled machining conditions. So this is ideal. And here is an example of swarfing I took from YouTube. There are many applications that you can see. And another one. So swarfing can be continuous swarfing, can be position swarfing, but as you use the side of the tool, you are utilizing the tool to its maximal capability. Next, the slotting. Here in this example, again, we have a slot from the side, which is actually a 3-axis from top. But if I use a slot tool from the side, I can very easily get to cut very narrow slots with a rather robust tool with actually a profile operation. So profile operation, it's a 2.5 axis operation. It's very stable, but I need to have a 5-axis software and a 5-axis machine for that. Pocketing. How can pocketing be a 5x? Pocket, it's a 2.5x operation. But if, like in this case, when I cut this pocket, I want the holder to be relieved from this geometry, I maybe pocket it from a constant tilt angle. And utilizing a constant tilt angle means for me actually a 2.5 axis operation. But since the tool is tilted, it's immediately a 5 axis. And I need for that a post-processor, and I need for that the application, and I need for that the correct machine that is capable of doing that. Imagine cutting this simple pocket from top. You are facing a dramatic technological problem. So that was positioning. Now, if we go to more complex operations, like continuous, then things get more challenging. Roughing and finishing with continuous operation. Here we have, for example, this area that we want to machine from top. And with a standard tool, there are areas that cannot be reached by this tool. So I will look for a longer tool. More areas can be machined, but still not all. So now I will use an extra long tool, and assuming I can machine all this area, we are now already facing an extra long tool. And that means if I look at the report, NC setup sheet report, we are looking here at a total time of 1 hour and 13 minutes based on the real feeds downstep and sidestep for that specific tool, 1 hour and 13 minutes. Let us now assume I'm going to cut with the same tool diameter, but with a very short tool. And this tool will run around this area in a continuous mode. Looking now at the report, it went down to 5 minutes and 15 seconds. Same tool diameter, same machining. So this is a dramatic change, a dramatic time save. Time save is money. And here is the application as it shows in the simulation. And here is same on the machine. So now, of course, we are utilizing the full 5-axis machine. All the axes are moving simultaneously. The holder is gauge checked and collision checked against the stock and the part and all the components of the machine. So this is really a challenge. Collision check, as I mentioned, this is a challenge, and if you have a very expensive machinery, you wouldn't like to see any collision of the tool and the holder or your clamping system. So this is really a delicate issue. If I zoom into this area now, and we have to cut this boss, when getting closer to the vertical wall, notice how the holder is extracting itself away in order not to collide. And this is done automatically by the software, and this is shown directly by the simulation. So once I go to the machine, I'm already safe because it was collision checked by the software. And then maybe the most important application of 5-axis is the tilting for finish and cleanup. Here we have this corner at the bottom of this feature, and this tool looks very good. I wouldn't say a problem here. If you use a shorter tool, okay, but this is not really dramatic change. But when we go to the final tool diameter and the final corner, this tool is so extra long, nobody will use this kind of tool at the shop unless he must, or he will go to EDM. So this means we are facing a challenge here. But tilting that with the same diameter, automatically we see a standard tool, and this becomes a non-issue. Simulating that inside the machine simulation window, you can see that the B angle is constant, 23.76. So actually this is 4-axis and not 5-axis. And 4-axis is better than 5, as I said before. As you move less axis, it's better. So it's a challenge for the software to produce a toolpath with 4-axis movement, and the 5th is constant and not changing. So this is how it looks in reality. And here is another one. In this example, you see the cavity being machined, and the table rotates very fast, and the surface quality is very good, and the tool is tilted in standard fixed orientation, and just the table is rotating. This is the best utilization of tilting. Pocket swarfing. In some cases you have a drafted pocket or a drafted lock or any geometry which is actually a simple geometry but drafted. So you can use a shaped tool, and that's fine. The shaped tool can do it in a one go, but it's a special tool, and this means if you now have a different pocket with a different draft angle, you have to use a different tool. So you have to keep in stock different tools, and those are rather expensive, and to grind them it's not easy. You can use the standard 3x milling, and that is fine, but this is time consuming. Or you can use a standard tool but with a 5-axis swerve tilting in order to machine the geometry, swerve it around in just one go. And this is a standard tool. So you can use even a different diameter, no matter. So this solution now is very attractive, and this requires the proper software to manipulate this kind of toolpath and the proper machine, of course. So here is the pocket swerving in one go. And the last is marking and engraving, where many times you need to write some text or mark anything on your component, on the mold. And this is normally done where you have to be normal to the surface and you have to be in constant depth to the surface. So this can be done only in 5x continuous. So those were some applications, and there are many more. So looking at the applications, we need to check that the application is strong and flexible enough to be able to program any geometry, any job type, any complexity level, but that is not enough. Many times you need a CAD for manufacturing support. CAD for manufacturing is different from CAD. It has to be available immediately when you need it. It has to be strong for those CAD operations which are typical for machining, and combining, of course, solid, surface, and wireframe. And in those operations, you need sometimes to mend geometry, to cap, to create extensions, construction curves, all those necessary jobs that are typical for CAD for manufacturing. Once you have those, you need to have the proper post-processor. The post-processor has to be capable, it has to fit all controllers and machines. I want this post-processor to fit my machine and my controller with workplane, RTCP, inverse time for the less expensive machines, and to support in-process measurement. Harry here, maybe you want to elaborate on that?
Well, Alan, my practical experience says that in many of the 5-axis implementations, post-processor is one of the key factors to make the investment successful. And I think it is very important to have proper post-processor for running this machine, because you're dealing with not just 3-axis but all the 5-axis. The safety of the machine is very important as well, and which is mostly controlled by the 5-axis post-processor. We always hear stories that somebody purchased a machine but hasn't been used in the way in which it should be because of the post-processor. So it's very important aspect of stepping up to 5-axis. You have to make sure that 5-axis post-processor can play a major role, and whatever the software you choose, and make sure that your provider, your person who is supporting that software can provide you a comprehensive 5-axis solution, fast and accurate. This is very important.
Okay, thanks, Harry. This is experience from the field. Thank you very much. Now, before we go to the machine, as I said, the machinery is very expensive, and we would like to run simulations on our screen before we go to the machine. And simulation has to be, first of all, reliable. It has to reflect the real cutting process, show the part and the fixture as it is set up on the machine table, show the exact tool and holders and the material removal, machine structure, axis direction and limits. At the same time, it has to be fast. We don't have enough time to wait now hours for simulation. It has to be run fast but reliable. And you have to have it handy, means you can move to any single block, jump to a certain block, and you have to have a clear notification of any error and message if appears in order for you to go back to the software, modify, and run again. So the simulation is a crucial element because it will give you the safety and save your equipment. And last is your CAD/CAM provider. As we heard Harry, the provider for you has to be with the knowledge and has to transfer the knowledge to you and give you all the backup, make the implementation for you with you on your machines and your controllers and your specific jobs, and then give the training and the support and the online help when you are in trouble in your shop floor. So all those together will make your CAD/CAM the correct CAD/CAM for your application, for your 5-axis. So what I'm saying now as a summary, 5-axis is not a want. It is becoming now a must-have in order to boost your productivity, shorten your delivery time, and improve your surface quality. And to summarize, 5-axis machining is a productivity and profitability booster today. Thank you.
Before we begin the question and answer session, I want to remind you all that this webinar is being recorded, and you'll receive a follow-up email with a link so that you can revisit the presentation whenever you'd like. Here's our first question. This refers to the presentation, to an image shown, and the attendee asks, what kind of cutter was shown in the video with the aluminum part and the green clamping fixture?
Okay, that was a movie I took from the YouTube. I believe it was what we call a barrel tool, a conic barrel tool. I have no further information on that.
I see we have another attendee who says, I have a 5-axis machine, but due to cost, I cannot afford the 3+2 or the 5-axis software. Can you just make a USC on the same angle as you turn the head of the CNC machine and lie to the software by saying that the part is on an angle when actually the head is tilted?
Okay, I'll answer it from a different perspective. Your machine at the shop floor is the most expensive component and your key for profitability and for productivity. Whenever you do not utilize the machine to its best capacity, you are losing money. Tools, holders, fixtures, automatic clamping devices, measuring systems, and software are all minor expenses relative to the machine. They all serve the machine. We need to feed the machine at the fastest possible because the machine is the tool that gives us the money. This is the productive tool. All the rest is to serve the machine. So I would say you could do, a patch of UCS, a manual, and so forth. But you invest too much time and too much effort in programming, and this is off. You are losing advantage, and you are lagging behind. I would go, don't be afraid, check it out, invest in the software, go ahead, take the training, and you will not be you will not regret it. In a year from now, you will look back and say, how could I program manually on such an expensive machine?
Another question asks, can we machine electrodes with 5-axis equipment?
Very good question. Thank you for this question. I didn't cover the electrodes, but of course, electrodes can be cut in 5-axis. We have customers. I visited a customer in Portugal who is doing all day just electrode machining with a set of 3-axis and 5-axis with full robotic cells with a very, very nice setup. So of course, 5-axis is applicable on electrodes very well.
We have another attendee who is concerned with the time that would take to ramp up to implement 5-axis machining and then to actually begin production.
Again, a very good question, because this is a very scary point, and I would say it's not the time, but it's a kind of a change in your mindset. Once you understand you have a 5-axis machine and you want to utilize it to its maximal capability, now the question is, how should I attack this kind of job? From which directions and what methods should I use? Once you are there, the rest is very simple. I mean, take the training and the implementation. It's a matter of few weeks and that's it. Then you are left with your own knowledge and with your own capabilities, and your mindset is a 5-axis mindset. Now you are in a complete new game.
Alon, I just want to add to that question.
Please.
It's very important that when you wanted to step up to 5-axis cutting, just not the 5-axis machine. As Alon was showing different aspects of the puzzle, if you don't plan them, your implementation can go wrong, and it can take longer. Let's say if you buy a machine but you didn't plan the work holding devices, you bring the machine, install, and then find out that, I didn't get the proper work holding devices, then you are waiting for it. If you try to use the 3-axis tooling on the 5-axis, then you will not see the results what you want. Similarly, if you don't plan better in-process measurement, like for example laser checking of the tools, because when you are in 5-axis, you are operating from multi-axis. So blending of various tools is very, very important. To see not any mismatch in the blending, you need to have the tool measurement very accurately done. And also you have to make sure that you load the tools properly. This brings up a very important, I will share it during my customer story presentation as well, that you have to have the proper software with the proper post-processor which can do some in-process measurements and caution you from any collisions or things like that. So yes, it could be scary, but if you go with the proper mindset, the implementation should be very, very quick. It shouldn't take that long at all.
We have another attendee who asks, what reasonable accuracy and repeatability can be expected from the best high-speed 5-axis machine?
Well, I would say walking around, as I said in Jim Tov show, or visiting the major machine tool makers like Mori-Seiki, Mazak, Makina, Okuma, the bigger ones, you will see how accurate it is. It's just unbelievable. I'm speaking in millimeters, not in inches, but I would say there is a huge gap of accuracy and repeatability achieved in the recent years. You just need to see it in order to believe how accurate, how smooth the machine runs, how fast they run. It's just a new game compared to 5 years and 8, 10 years ago.
Here we have a guest who is concerned about a situation where he's already cutting electrodes and says that in order to hold such extremely tight tolerances, he has to run 3+2. Do you have any suggestions?
3+2 is very good. 3+2, if you can complete the job with 3+2 with short tools, that's the best. If you have to utilize 5x continuous, this means you couldn't do it very well with 3+2. So once you get to 5x continuous, that's okay, but this is more complex programming with tilting and then simulation and so forth. So if he is happy with 3+2, that's just fine. We're not pushing to exotic continuous motions, absolutely not. But it's kind of another tool in your toolkit. You can choose it whenever you need it. If you don't need it, use it simpler like 3+2.
Now the question arises having to do with existing machinery. Can you control my older machine? One of our attendees asks.
Harry, do you want to answer that?
Yeah, basically as a software vendor, we can support any machine tool, whether it is old or new, really does not matter. I had a personal experience with one of our customers here. He had a plant set up in Mexico, and one of his older 5-axis machines, he moved out there and he said, Harry, I want a post-processor for that. They asked me for a positional post-processor for that because all these probably 10, 12 years, they were of the opinion that that machine was only a 3+2 machine. But when I went down there, when I started looking at the controller and started making the post, I told this machine is capable of cutting 5-axis continuous, and they were all in awestruck, So older machines does not mean that they are not good. They may not be as fast as the newer machines. Of course, we can support any of the machines they have, no problem.
Well, gentlemen, I believe that we have addressed all of the questions that have been submitted so far. I'd like to thank you for a fascinating talk with us today. Thank you so much for joining us. Thanks to all of you in the audience as well. We'll hope you'll find this information valuable. If you have any other questions, or if you're viewing a recorded version of this seminar, please feel free to email our speakers at the address listed on the screen. On behalf of Modern Machine Shop and Cimatron Technologies, thanks again for your time and interest.